In this video, we're going to look at chi-square test procedure for the goodness of fit test for normal distribution. So step 1 is to set up the hypothesis. And again, the null hypothesis is that the random variable follows normal distribution, or you can say population follows normal distribution. Okay. The alternative is that random variable or population does not follow normal distribution. Okay. Let's look at an example. Here we have a company that hires employees, and when they hire employees they give an aptitude test, and the company director, personnel director, wants to know whether the test scores follow normal distribution or not. So we can then use that in hiring decisions. Okay, so he takes a random sample of 50 job applicants, and the aptitude scores for those 50 job applicants are given here, and we have the raw data. Okay. So our hypothesis then is that the aptitude test score follows normal distribution versus aptitude test score does not follow normal distribution. So that's your step 2. From that sample, then we compute x bar and sample standard deviation. Yes, let's look at how to do that in Excel. So we have a population, aptitude test score, and sample. I already have the data in a column, and the data is named score. So sample is count of score, x bar is average of score, and stdev.s of score is our standard deviation. Now the null hypothesis, the aptitude test score follows normal distribution with mean 68.42 and standard deviation 10.41. And the alternative is that it does not follow normal distribution. Now let's use 5% for alpha. Okay. Now let's go back to the steps in Word document. So step 3 is to set up the table a particular way. We want to make sure that the expected frequencies for all the rows will be 5 or more. So what we can do is we can take the sample size and then divide by 5, and that will give us the number of classes we need, such that we will have 5 as expected frequency for each class. And we need to round this ratio down. Okay, let's do that. So we use the int function, n over 5. Then we do 1 over that number of class intervals. That will give us probability for each class. So 1 over k is the probability for each class. Then we can set up the column of cumulative probabilities with the last class having a cumulative probability equal to 1. So we do that by first class is just 1 over k. The next class, cumulative probability, is the previous class's cumulative probability plus the probability for each class. And probability for each class must be absolute referenced. Now when you copy that, it goes all the way up to 1. And let's center that. The next step is to find the class intervals themselves, the upper limit for each class, and that is given by norm.inv function with cumulative probability and exponent s. So let's do that. These are the upper class limits. So norm dot inv, cumulative probability is that, and we use x bar for mean, absolute reference that, and s for the standard deviation, absolute reference that. So that gives us the first upper limit. We copy that down, and that gives us the upper limit for the rest of the classes. So we'll continue this problem in the next video.